Greetings. My name's Sean Thurston. This is Dr. Stansel's genetics class with Doane University, and this is my presentation on a rare genetic disorder. The disorder I chose to research is called Methioninemia. So, let's get into this. Methioninemia, that's an excess disorder of methionine. Methionine is a non-essential amino acid and building block that we all have and carry, but you can supplement it. It's pretty popular to supplement right now because it's known to burn fat. You can do IM injections, intramuscular injections, IV injections, or pills, and it's something you can supplement it as an amino acid. It's a rare inherited disorder, and it is really not life-threatening at all, which is good. I'm glad to research something that's not killing so many people. So it's linked to creation and opening of new and damaged blood vessels and new and damaged cartilage. It's also known, as I said, to burn fat. So a lot of people are jumping on the methionine train right now. Methionemia, it's a precursor to other amino acids. So when it starts its thing and kicks in, it activates other amino acids such as creatine, taurine, and cysteine. Methionemia can also happen as a result of another ailment. So something such as homocystinuria, that's a disorder of methionine metabolism in the blood. Your levels are going to go up. Tyrosinemia, which is another, it's a flow chart here, that's another amino acid. If you have an excess of that, your methionine levels are going to shoot up as well. And galactosemia, which is a sugar. If you have a buildup of galactose, which in the Western diet, we really don't need a buildup of a sugar. Guilty. But if we have a buildup of galactose in our blood, then your methionine levels are also going to go up. Although methionine is a necessary amino acid and it's non-essential, meaning we all have it, people with methionemia don't usually show any symptoms of this. It's just not something that we see. Unless you let it go a long time and don't take care of it, and most of the time you're not going to know. So people who have it, they present themselves as kind of buzzed. They're chronic fatigue, sluggishness, slurring words a little bit, not speaking correctly, just someone that seems off. If it's prolonged long enough, so I guess if you have methionemia at birth and you don't treat it until you're in your maybe 20s or 30s, you may develop liver problems. But again, you may not even know. If it goes long enough, body secretions you have will smell similar to boiled cabbage. Sounds lovely. So how does methionemia happen? There are mutations in 3 different genes where this can happen. The protein coding gene, the adenosyl homocysteinase protein coding gene, or AHCY, which is what I should have said. If there's a mutation there, your methionine levels can go up. The GNMT, which is your instructor gene for the enzyme glycine, glycine and methyltransferase. If you have a mutation there, methionine levels go up. And then the MAT1A, the methionine adenosyltransferase protein coding gene. If you have a mutation there, methionine levels go up. All the enzymes that break down methionine are located in those 3 genes, and if they're mutated, it's not going to work out so great. And your levels will go up, but you'll be okay. So the cytogenic location for methionemia, that's 10q22.3, the long arm of chromosome 10 at position 22.3 right there. All right. Methionine, the mode of inheritance, it is a autosomal recessive gene. So there's a 25% chance of offspring having it if there's 2 parents that carry it. if both parents are carriers. Males and females, same exact passage rate, no specific demographic or group or ethnicity, nothing, there's nothing. And that leads to the next point. Methioninemia is so rare. The number of reported cases is significantly low. It barely is registered on anything. Pretty tough to find and find out. Here's a good old Punnett square. This is going to show if you've got two adults, two parents, unaffected but carry. Here's your result, and this is that, boom, that 25%er right there. But everybody's going to be healthy overall. And even if this double lowercase a one has it, they'll be all right. And the pedigree, it's going to show also what we've got. The black box you can see is the affected patient. So you got two parents from that Punnett square like I just did, and your result of the 4 children turns out the same. Both uppercase A, unaffected, not carrying. They hooked up with a unaffected, not carrying one too, and had 2 unaffected, not carrying kids. The next daughter, the oldest daughter, just like mom and dad, unaffected but carry, with an unaffected, not carrying, 2 healthy boys. Third child, the boy there, we've got, oh, I didn't write it, but that is a unaffected carrier who shacked up with an unaffected carrier, but they had 4 kids, and one of them has Methioninemia. And it can be treated though, so we'll go ahead and explain how that couple can help their child with their Methioninemia. But the 4th sibling, the youngest one, youngest of 4, that would be me in my family, by the way, but it's a female there. Double lowercase, so affected and carrying. But they had 2 kids that weren't affected. That's not fair. Anyhow, that's the way it works. You got some carriers, you got some totally unaffected kids, and then 2 affected ones out of that whole mess there. Family reunions gonna be fun. Some of them can't eat certain things. That's how you treat it. Okay, here we go. So, options for genetic testing. It's on the panel for the newborn screening tests, which is in all 50 states now. You get a splat of blood from the kid's heel. It's gonna check for hundreds of things, and Methioninemia is one of the things that they check for. Various types of disorders, many, many, many. If you are curious if you have elevated methionine levels, you can get a CMP. ProHealth, LabQuest, LabCorp, all those companies. You can go find out what your methionine levels are. If you're a bodybuilder, you might want to know. If you're trying to lose weight, you might want to know. 23andMe can tell you. You can go to an IV bar and get a genetic test done, and they will tell you what your level is, and you can supplement it if you want to. But it doesn't seem to be a big deal. Unless your body doesn't produce it for some reason, then you might want to get some shots. So, treatments. I wish this is the result for so many other ailments that we have. Your diet is the treatment. That's a big fat hint for everyone, including myself. Your diet is the treatment. Maintaining an adequate diet with lower protein levels will help keep your amino acid funk from happening. But I don't think you really would want that, but that's a different topic. Most often the symptoms of Methioninemia are not by themselves, but a good clean diet can help with that. Plenty of water, things like that. I wish I could take questions, I can't, but this has been a fun class and I really appreciate everyone checking this out. I wish you the best. Thank you. There's some references.